Welcome back to Basic Biostatistics 2, to session 5, which is about ANOVA tests, and to the second video. In this second video, I'm going to show you how to make multi-way ANOVA or multifactorial designs when testing for differences between three or more groups. Let us assume that we would like to test whether there's a difference in the cholesterol level among the three physical activity groups. However, this time we would like to adjust the analysis either for age, or we'd like to see whether that difference is persistent also among all smoking categories, meaning that the difference in cholesterol among the physical activity categories is the same among smoking or non-smoking dwarfs. Smoking in that case is also an interaction or an effect modifier. So we'd like to see whether for the both strata of smoking among the smokers and non-smokers there are differences in cholesterol level among the physical activity categories. In addition to effect modification, this is sometimes also referred to as interaction. So smoking status interact with physical activity category in regard differences in mean cholesterol levels. How to do this in SPSS? We go to Analyze, and in Analyze we have under Compare Means with General Linear Models, or GLM. Here we choose Univariate, and Univariate opens us the correct test to see whether there are interaction terms. The null hypotheses in this case are three. The first null hypothesis is that there's no difference in the mean of cholesterol among the physical activity category levels. The second null hypothesis, there's no difference in mean cholesterol level between the smoking categories. And the third null hypothesis, there's no interaction between physical activity and smoking. In SPSS, we solve this problem rather easily. We select cholesterol, which is our main dependent variable in the dependent variable window. The fixed factor will be the physical activity category we're interested in. This is our main variable of interest. We scroll down, we find physical activity in categories, we choose the fixed factor window. Now, if you'd like to adjust the analysis for age, for continuous variable, the continuous variable will be added as covariates. If the variable we'd like to test is categorical, and if you'd like to test the multifactorial designs and interaction, we choose the categorical variable and we add it to the random factor window. In my example, if you have a categorical variable, I'd like to see whether among smoking categories the difference in cholesterol levels among the physical activity groups is the same or different. In other words, is there an interaction between smoking and physical activity on cholesterol level? So I choose as a random factor smoking status, and I move it to the window random factor. This is all we have to do in this window. We have here a couple of different options we have to select. First one, when you go to model, you see there's already full factorial model chosen. This is perfect because we like to have the mean values for physical activity category, we like to have a p-value for smoking, and we would like to have the interaction term. So we do not have to change anything here, we just continue to the next model. Now, sometimes we like to have some graphs. So in this case, we click on plots, and here we can select if we'd like to see the difference in cholesterol level for physical activity category and smoking in a graphical way. We choose physical activity for the horizontal axis. We choose smoking for separate lines. This gives us separate lines for smokers and non-smokers in regard to mean cholesterol level according to physical activity category. Before we program it, before the program knows that we want to line, we have to click on Add. Otherwise, no plots, no lines will be shown. Once you click on Add, we see here now we have programmed that the plot's going to be physical activity category and smoking. Once we have defined the plots we'd like to have for our research question, we click on Continue. Under post-hoc tests, we do not have to do anything, and I explain you why. Because we go to Options. And in Options, we can select that display the means for the physical activity categories. We can also select the means for smoking categories. And for instance, when you choose physical activity category, If we like to have the means for the physical activity categories, we can click here compare main effects, and you see the LSD test is already chosen. I also like to have the mean cholesterol levels according to smoking, so I choose smoking and move it as well for the category. As smoking is a dichotomous variable, there's no need for compare main effects or for LSD test, because if there's a difference, it's between the non-smokers and the smokers. In physical activity, as remember for one-way ANOVA, we have 3 different categories, and we would like to know whether there's a difference category 1 and 3, category 2 and 3, and category 1 and 2. Additionally, I suggest you to choose descriptive statistics, gives us the mean values and the standard deviations. You remember that we are also interested in homogeneity test, as one of the assumptions is that the continuous variable cholesterol has the same variance according to subgroups. We click on OK and continue, and now the only thing we have left to do is click on OK. This is how we define the host model for the factorial design or the multi-way ANOVA. Clicking OK opens us the window with the results. As usually, we have first a between subject factors effect that gives you more or less the 2 categorical variables we have. We have the physical activity category variable consists of 3 categories. Smoking status consists of 2 categories. The value labels no and yes, and for physical activity low, moderate, and high. It also tells us how many people in each category. The second table is descriptive as well. It tells us actually the mean values of cholesterol for the low physical activity category according to smoking status. So for the low physical activity dwarfs who do not smoke, the mean value of cholesterol is 6.54 with a standard deviation of 0.69. For the smoking dwarfs who have low physical activity, the mean value of cholesterol is 6.8 and the standard deviation is 0.346441. And so we can check the same for the moderate physical activity dwarfs. You see there seems to be almost no difference. We can go to the high physical activity dwarfs, compare the values between non-smokers and smokers, and here actually it seems to be that the smokers have lower cholesterol levels than the physically active non-smoking dwarfs. We also have to keep in mind that dwarfs are very different from human beings. They may have some effect that cope with it. In the end, we would like to know whether this difference is statistically significant. The next window shows us the Levens test of equality of variances. You already know that what this is. One of the assumptions is that there's no difference in the variances among the subgroups. The null hypothesis tells no difference in variances. The p-value in our example is bigger than 0.05. This means that there's no statistical significant difference in the variances, and we can continue using ANOVA tests. If this would be non-statistically significant, we could not continue with Multiway ANOVA, but we'd need to use a non-parametric test. The next window tells us the actual model, tells us the answers to our null hypothesis. First of all, physical activity category. The null hypothesis was there's no difference in cholesterol level according to physical activity categories. It calculates an F value and the corresponding P value. This value is less than 0.05, so we reject the null hypothesis and we state that the cholesterol level is different across physical activity category. Statistically significant different. What about smoking? Well, smoking we have here in the second row, and the F value is pretty low, 0.112, with a p-value of 0.76, which is clearly higher than 0.05. This means in respect to smoking, we accept the null hypothesis and we say that there's no difference in cholesterol level between the smoking and the non-smoking dwarfs. What about our third null hypothesis, that was, is there an interaction between physical activity category and smoking? The null hypothesis is there's no interaction. And if you go to that interaction term, the F value, and check the p-value, we see the p-value is bigger than 0.05, and we conclude there's no interaction between physical activity category and smoking. So the difference between physical activity categories is the same and the same direction according to the non-smoking dwarfs and the smoking dwarfs. If this interaction term will be statistically significant, then this would mean that the difference in cholesterol level between the physical activity categories depends on smoking status. For instance, among the non-smoking dwarfs, they may have a lower cholesterol among the low physical activity groups, and among the smoking dwarfs, the difference may be different, favoring the low physical activity or the high physical activity dwarfs. So there will be an interaction of smoking. The last tables basically are summary tables. That expected mean square table we can omit, it's not really important. Here when we have the estimated marginal means, remember we selected to play the means according to physical activity categories. Here we have the mean value, the standard error, the lower and the upper bound, and then again the LSD test gives us the pairwise comparison. So we can see that there's a statistically significant difference. I see here the p-value is less than 0.05 between the low physical activity and the moderate physical activity dwarfs in respect to cholesterol level. The mean cholesterol level is also statistically significant for the difference between the high physical activity level dwarfs and the low physical activity level dwarfs. And here we have moderate versus low, as we had already here, significant, and moderate versus high, also statistically significant. It gives us then a univariate test that's basically the same, telling us that the pairwise comparisons are statistically significant. You do not have to bother too much about that table. It's sort of a repetition what you already have of the main ANOVA result table. And then we have the same for smoking status. We have the mean value for the smokers and non-smokers of cholesterol. You see they're basically identical. And if you have a look at the pairwise comparison, which is comparing no smoker with smokers of the mean cholesterol level, the p-value is far above 0.05. So no difference in mean cholesterol level among the smoking and the non-smoking dwarfs. The last thing that is important is profile plots. We can see here we have two lines. We have here the cholesterol level of the dwarfs. We have here the three physical activity categories, low, moderate, and high, and two separate lines, one for the smoking dwarfs and the non-smoking dwarfs. A basic rule is that if the lines are more or less parallel, there's no interaction. If the lines clearly cross and go to the opposite direction, for instance the blue line goes down and the green line goes upwards, then there's for sure interaction, meaning that the effect or the difference of cholesterol level depends on smoking status according to the physical activity categories. This is everything I wanted to show you in Factorial Designs ANOVA and Multiway ANOVA. One more thing in regard age adjustment. If you go to analyze, go back to general linear models and univariate. If you select instead of smoking status, we like to have age adjusted our analysis. As in many studies, you would like to have age adjusted results, age adjusted whatever. So we choose age of the dwarfs and we move it to the covariate window. In that case, if you run the analysis, you will not get any profile plots and no post hoc test because age is a continuous variable, but you will get all the results of our study adjusted for age. We will actually get a two-null hypothesis telling there's a difference in cholesterol level according to physical activity category and the difference among each of the different ages that doesn't make much sense, but that age is a factor to be adjusted for. And then we receive age-adjusted means of according for each physical activity group. We also get pairwise comparisons, and as I told you, we will not get any plots because age is a continuous variable. However, this goes a bit beyond the scope of this course. Important is that if you add categorical variables into the model, you can have cluster or multifactorial designs and test for interactions. If you add a continuous variable into the model, it means the results are adjusted for that variable. Thank you very much.